Hi, I'm Rose. I'm currently an intern with a startup company that is renting out servers for AI development, and I'm also a master's degree student in a smart city engineering program. So, the last time I did a video, I was starting on covering the topic of the development of AI as a field, and I went over Ada Lovelace, Charles Babbage, and Alan Turing, and I will be continuing going over that today. So after Turing, Lovelace, and Babbage, there were a lot of different characters and breakthroughs that contributed to the development of the field artificial intelligence. So I'm going to be talking a little bit about what brought us to where we are today. So in 1956 at Dartmouth College, there was like a team of researchers, and Marvin Minsky and John McCarthy were two of the researchers on this team, but they contributed pretty heavily to this field. So John McCarthy is known for coining the term artificial intelligence, and Marvin Minsky is kind of known for researching what quantified as cognitive intelligence in machines. So these two continued to collaborate on projects in the field. And this first project was kind of like this defining moment of the field of artificial intelligence as a field. So, from the beginning, researchers really disagreed about how to go about training an intelligent machine. In 1948, Turing came up with two theologies, and there was major disagreements in the field about which one was better. So the first one, and this one was pursued earlier on, it was rule-based learning or symbolic learning. Essentially, you would feed the computer a bunch of rules, like if it has a tail, and it has a snout, and it has paws, it's a dog. This is a dog. This is what makes a dog. And the machine would take whatever it was and run it against all of these rules. And if it met all of the rules, it would be like, yeah, this is a dog. But this tends to break down because in life, things don't always follow all the rules, right? But there was a machine called Mycin pretty early on, that was a rule-based learning machine in the medical field, and it was pretty accurate when it came to predicting things based on this rule-based learning. It really wasn't trusted by people in the industry, though, because yeah, if something is outside of the rules, then it tends to break down, like I said. So the other approach is a bottom-up approach. So you feed the machine a bunch of images or instances, and the machine writes its own rules. And this is called machine learning. So earlier on, this wasn't as popular because machine learning requires a lot of data, and that data just wasn't available yet, and it requires a lot of processing power, and that really wasn't available yet either. So in 1997, we start to see the field of AI, artificial intelligence, kind of coming onto the map. It kind of was starting to enter into people's awareness. And this is because that was the year IBM had introduced this Deep Blue chess playing program. So this was a top-down approach at an AI. So it was really good at playing chess. And it actually defeated the reigning chess champion at that time, who was Garry Kasparov. And at that time, that was really big. The headlines in the newspapers were pretty much like, machine beats man. In the early 2000s, there were three researchers, Yann LeCun, Yoshua Bengio, and Geoffrey Hinton, and they were all working on something called deep learning. So deep learning was really the building of neural networks in these programs. They were like these mathematical systems that were just loosely inspired by the human brain. What they did was they had these nodes, interconnected nodes at many different levels. And these interconnected nodes at different levels really allowed the program the ability to process data, extract complex features, and really make predictions without any kind of rules. So these three researchers really didn't receive any kind of recognition for years, but in 2018 they were awarded the Turing Award. So deep learning itself became more practical around 2010 because three things were kind of coming together simultaneously. Algorithms were becoming more complex. We had infinitely more data. By 2010, there was data to train these programs from just an infinite supply of human-generated text and behavior and images on the internet. And then we had a massive increase in computing power. Because of the GPUs and graphics processing units required for video games were actually just like perfect for all of the parallel calculations that were needed for these systems to process optimally. So let me kind of leave you with this. AI is a very broad field. And an AI system is kind of any system that can think, learn, adapt, etc. Whereas machine learning, it kind of hones in a little bit. And machine learning is more like systems that can learn from data that don't inherently need rules to learn. And then deep learning is narrowed in even more, where it has these complex networks and it takes a lot of data and a lot of compute power. So in 2026, a lot of people that refer to AI are referring specifically to deep learning chatbots like ChatGPT and DeepSeek, when in reality, the field is a lot broader than that.